So in this video, I will talk about delta hedging and some shortcomings that come with this strategy. And this video will be an extension of the previous example, so many of the concepts here will be just a recap of what I've already covered. With that said, let's get started. So remember from my previous lesson, we had a call option that matures in 1 year with a strike price of $105, where the current price of the underlying is $100. And remember that we had an investor that reached out to a trader and said, I want to buy 1 million of these call options, how much would you charge? And then the trader, before giving a price, goes ahead and calculates the theoretical value of this call option by using the Black-Scholes model. He gathers the additional inputs he would need, such as the risk-free rate and the volatility of the underlying. And once we have these inputs, the valuation of the call option is a simple plug and play with a bit of work with the cumulative distribution function. And long story short, the theoretical value of this call option is $9.56. And based on that, the trader is like, okay, so the theoretical value of this call option is $9.56. So let me sell them at $10 per option. So the trader gets back to the investor and says, sure, I will write them for $10 per call option. And after this, the two strike a deal. And of course, the trader is very pleased by having made a gain of $0.44 million. But of course, things aren't that simple, because through this deal, the investor is now long 1 million call options, while the trader is short 1 million call option. And as we all know, whenever there is a short position, the potential losses are theoretically unlimited. So the question is, how can the trader manage this risk? And this is where the curriculum introduces delta hedging, which basically means to buy delta units of stock per call option that the trader is short. And of course, to execute the delta hedge, the first step is to calculate the delta of the call option, which starts with calculating D1. And basically, calculating D1 is a simple plug and play. So if we plug in the values, we would get D1 to be this value over here. And this is just a recap from my previous lesson. So in order to calculate delta, we need to plot the D1 value on the cumulative distribution function, which is a symmetric normal distribution with mean of 0. And if we go ahead and plot D1 on the cumulative distribution function, it would be somewhere over here. And this is just a quick recap, something I've emphasized many times in my previous lessons, and that is that ND1 is the delta of the call option, which is basically the surface under the curve from -infinity until D1. And of course, this is something that can be looked up in statistical tables, and in this case, it would be this value over here. And what this value means within this context is that we need to go long 53.58% of the stock in order to hedge a short call position. So basically, the hedging strategy the trader needs to take is to buy around 500,000 of the shares of the underlying. And now let's ask ourselves, does this hedge work? And in order to test this, let's assume that the underlying stock price has increased by 20 cents. And if we run the calculation, the 1 million short call position would decrease in value by this much, while the long position in roughly 500,000 shares would increase by the same amount. And the math is right here on the screen. I will not go through every step, but feel free to check it if you want to see how it comes together. So basically, delta hedging is a nice, neat little strategy, but the key takeaway I want you to walk away with is that delta doesn't remain constant. And this is because changes in the underlying price automatically result in changes in delta. As you can observe in the formula, D1 is expressed in terms of the current price of the underlying, so any change in that will trigger the change in D1, which in turn leads to a change in delta. And for this reason, the hedge needs to be rebalanced frequently, and that's the very reason the delta hedge is not a hedge and forget strategy. And before I wrap this lesson up, there is one more point the curriculum mentions at the conceptual level, and just in case, let me mention it as well. And that is that if the Black-Scholes assumption hold, the total discounted cost of daily delta hedging closely matches the option's theoretical price, which in this case is $9.56. Now, this is something that has been verified by running Monte Carlo simulations, but looking at this from a testability perspective, I think you can reasonably consider this as something abstract without the need of over-analyzing it.